Unboxing this big package. Where's it? It's come from the USA, priority mail, and it had a whopping £103.66p charges to pay before I could even get it out of customs. So what's in it? Well, before I open it, I can tell you I did order this from miniPRO. It's a dyno, electric motor dyno, and this is from their site in the USA where you can buy it. You can see the basic kit model is $394.99 US dollars. There are some options you can buy, and it's also hooks up to this thing called the Chassis Dyno, which can be 2 or 4 wheel drive, I believe, and it's a whopping $699.99. And it does it says the Chassis Dyno measures RPM, kV voltage, current draw, torque, etc. and for motor analysis, and I believe it connects up to the flywheel, I hope, and the two go together. So quite expensive package, and it costs some import duty as well. So I haven't opened it yet, so come in this here. And this has got a packing slip. Says it's got throttle control sensor, quick swap motor holder, which I did add additional to the actual dyno itself, and it's also got the Chassis Dyno kit, no flywheel. So it's as ordered. Inside, got electric motor dyno, comes in this nice box. I'll have a look at that in a second. And those are the optional parts that must be I ordered, which is the motor, quick release motor holder, I think. There's some cables. There should be an electric board. Now this is the base plate for the dyno, which will be a rolling road style. It's got some of this. Well, it rolls along the table. As you can see, it's got a thing for a belt there, rollers, adjustable, there's some screws there for adjusting the length. Without instructions, I'm not going to do any more with that. Just look in this bag here, parts for the flywheel, not sure, for the dyno. That looks like it's a flywheel based sub-assembly, some sort of neck strap, there's a belt and some cables, so they don't seem to be the additional parts that I ordered, so maybe they're somewhere else. Here is the electric motor dyno box. I'm hoping you put the other bits inside. A quick start guide. Oh yeah, these are the extra parts I ordered. The quick swap motor holder, good. The throttle controller. Again, this is dyno. Nice and small, whole electronic board in the side. It's very professionally made. You can feel that the actual flywheel is encased. Got a guide here, so we've got to put that together. Voltage current sensor. I did ask for the high current one, the 180 amps, which is just a little modular board. There's the original motor holder, and this is the quick release one. I think with the original one you have to bolt the motor on. With this one it clamps around the motor. Hopefully that'll make it a bit easier to use. Flywheel based sub-assembly. There's a USB lead and the belt and pulley for the motor. Okay, that's it. So hopefully it'll be straightforward to assemble. There's a quick start guide. Oh, download the instructional guide. There's also download software and driver. Make sure pin 2 is only on. Your dyno is already pre-confirmed. Whatever that means. You do not need to change your switches or update the firmware unless a new version was released. You do need a laptop or a computer to get the best out of this. In fact, I think you probably need it anyway. I don't think you can get any results from the electronics here. There is another electronic unit, I believe, that shows some results, but it's never in stock, so I couldn't order it. As far as the this thing goes, I guess I have to download the instructions. For that, it doesn't seem to be, there's not a lot to it. So, and I also think it's probably best, this probably needs to be mounted onto a board or something, because it probably moves around at high revs. Same with the dyno. I've seen some other people mount it onto a wooden baseboard rather than just put it on the table where you could knock it over. So that's the next thing to do, and I'll get all the bits for that and screw it together. Also look online at miniPRO.com and have a look at any other information they want to give. You're going to have to mount the Rolling Road onto something just to make it nice and rigid, because the frame can twist around on its own. You couldn't just use it on its own with something on it. So I found this old bit of wood cabinet door or something, which is just about the right size, or you can get something much thicker. There's some holes in the rails, and I put some rubber feet on as well, which I had around just so that it can absorb some of the vibrations when it's running. So 4 screws or bolts or anything, and then this, you loosen off the screws and this can slide in and out now, so that you can get the size of your car or whatever, buggy, 12th scale, and so that you can set the length. So the wheels are on top of these rollers, and then you can do up the screws, 2 mil, quite small, tighten them up in the right position. As I said, this can slide quite a long way out now for large vehicles, or right in. For small ones, if it's only a rear wheel drive, obviously you won't worry about the front, just the back. If it's 4-wheel drive, you're going to have to rest it on both sets of rollers. It's got the pulley here. I haven't actually looked to see how the flywheel mechanism bolts, where it bolts on. I hope I've left some room. Anyway, you do need to put it on a board. I've got 4 feet, and there's a couple of screws in the middle as well, just to make it really rigid, and that means you can put it away, carry it, and it doesn't twist all out of shape. So that's something you're going to have to do even before you start using it. Now the other one, which is the dyno, again the same sort of thing. If you just put it on the table, it'd probably be okay, but I mean you don't want it to vibrate or fall over or anything, so you might sort of fix it to something. I had this actually this lightweight piece of board. I just cut it about the right size. This plate comes with it, and just for bolts, screw it to the bottom, and then you can screw this somehow. There's a couple of holes in this plate, 1, 2, 3 recessed. They must be the ones for screwing it down. Just leave room on the end, and I can put some rubber feet on this as well. I'll probably some stick-on ones just to absorb any vibration. A bit of working area. You can fix down your speedo, battery, whatever, and the electronics can all go on here, and makes it nice and neat. Continuing the assembly of the dyno, I've got the board that I showed earlier, and I've screwed this on with the 3 screws that fix through here to underneath. I put some feet on this, just a little, some rubber feet or something. Now, on here you've got the belt which connects to the motor. There are 2 alloy pinions or belt pulleys that come for the motor. They're held on by 2 grub screws, 1.5mm driver. One must be a spare. And it goes on there, and you line it up with the flywheel. Oops, making a funny noise. And you adjust it with 2 screws underneath, this way to get some tension so that it's not going to slip. You can also adjust the motor backwards and forwards with 2 screws down here. I've taken, oops, let's go back a bit. I've taken the side off. There's a part on there which is brown when it comes, because it's a piece of perspex, and it had protective paper on both sides to prevent scratching. You have to undo the bolts to take it off, and then you can fix it back on. And it shows you the flywheel inside, red one, but because there's no marks on the flywheel, you can't really tell it's going round. So I might paint, you could paint or put a black line on it if you wanted to see it rotating. Otherwise there's not much point to this inspection thing except to see that the flywheel is red and it's not broken. You know if anything's going to happen. I mean, it's attached to this and it's going around. Anyway, it's just a little feature, but you have to take the paper off it if you want to see through it. The same for the belt guard if you're going to use it. It's a piece of perspex with a paper covering on it. Stop it. Just, you can snap this. It's not that strong, so I don't advise bending it. Layout I'm going to use is I'm going to have this speedo. I'm going to use a Hobbywing 3.1 at the moment. I use for testing the motors, keep the same speedo. I've just fixed it on with some Velcro at the moment, sensor wire, and I use crocodile clips which I've wired onto the end of the crocodile clip to get the maximum current flow, just so that I don't have to solder everything on. I'm going to see how that goes. It works alright on my other dyno that I had. So I've got the 3 crocodile clips, so they come off the speedo, fairly short leads, and they clip on ABC, and you can plug in the sensor wire as well. Off the speedo you've got your plus and minus here. Now with this I put the battery up the back, and you've got this which has to be wired up. It's the current sensor. and it goes, you've got a plus and minus on the board that you have to solder the two wires onto. You're going to have a plus and a minus coming out of here, so I'm going to have to make up a little connector lead. There's some wire included, some reasonable heavy duty wire, but you need connectors to whatever LiPo you're using, 2S, which have got to come out of there and solder onto this. Then you take two wires out of there which have your socket or connector, whatever you're going to use, that's going to connect to your speed control. Most of the speed controls I deal with have bullet connectors. Some people use Dynos and some people use XT6s or sorts. You can have adapters or whatever it is you're going to be using. Can be, if you're going to test someone's speedo or something, you're going to have possibly adapters. Anyway, I'm going to have bullet connectors. So that's just a little bit of wiring that's got to be done. I've got to wire off of this to two connectors and off of that into the LiPo. I put the LiPo there and that there. Now that connects into the back of this with a supplied 3-pin lead, and I'll show you that in a second. It's just in the back here. There's two 2-pins, one 3-pin, and then these, I think they're 4-pin, two of them which are not used. We're going to use the 3-pin one. Supplied cable goes to the sensor. There's also a USB socket and a USB lead supply, which is one of the ones that goes off to the computer. And as far as I know, those are the other connectors that we're going to be needing on that board there. Now, I'm going to use the optional connector. I'm not going to use the transmitter. I'm going to use this board, which connects to the computer also, so that the receiver lead comes out of the speedo, plugs into here, and again a supplied different type of USB lead. It's got a different connector, it goes in there. So you now got two USB leads which are going to go off to the computer. So quite simple and neat at the moment. Motor, speedo, connector, this to be wired up, which I'm going to do. Now going back to the motor clamp, I wasn't 100% liking the way it came. I've got the optional clamp. If you get the one that comes with it, you have to bolt the motor on with the screws into the front of the motor. It seemed like a long process. I wanted to keep it as quick as possible. Now this clamp is fixed to the plate. You can only have it round one way, so this screw, this nailed screw here, undoes, and to remove this I just pull it like this and the belt comes off. Now when it came, it had this red part screwed on here with another red part on it, which held a belt cover, probably a health and safety thing, but it just got in the way. I couldn't see what I was doing. I've taken it off. I've taken the whole thing off because it doesn't seem to do anything except hold this. Now when I put this on, I can just put the belt like that. I just slip it round the pulley on the motor, and then the motor just goes in like that. You can line up the belt nice and straight. Next thing I've done, I found that the clamp on its own is very hard to tighten up tight. It's got some clearance around here for different size motors, I assume, otherwise it wouldn't go in. And it's one piece, it's not hinged, and it relies on a bend in the alloy. And done up tight, I found the motor, some of them are a bit undersized. I just couldn't clamp it. That's, doing it up as tight as I can, it still slips. So what I did, easing this back off, it could do with a bigger nut in my opinion, a much bigger one. I decided to cut a bit through on the back of this clamp. It was so difficult to screw this down to get any clamping because of this very large, well, there's no hinge, it was just this big bit of aluminium you're trying to bend. So I cut an additional depth of slot into the carefully, so not to go all the way through, adjusting it a bit by bit. About halfway through, I've also fitted a Teflon washer under here, which makes it much easier to screw down before this alloy part and that alloy part don't go well together when you're trying to turn it. They're just biting into each other. Now with a Teflon sort of, or you could use some sort of plastic, it gives it some sliding when you're doing it up, and it's much easier to turn and get a good clamping action now. So with the Teflon washer and cutting this a bit thinner so it can actually bend, I think that's going to work a lot better now. It holds the motor with almost perfectly tight now. So they've got some holes here. I don't know whether they intended originally to cut that through and put some sort of hinge on there, but that's better. At least it can bend a bit now. Now that I've modified the clamp, it holds the motor really well now. It won't twist. I still got the clamping very near the front of the motor. The reason why that is, I've adjusted the assembly back and forward so that this belt is fairly tight. You don't want it loose. Belts run fairly tight like that and in line. Now, so to make this easy to use, you undo the screw, and you can, as you pull it out, the motor twists and the belt jumps off. So then you can easily fit this on the next motor you're going to test, and you just need to hook the belt onto the end of the motor like that, and then you can there's just enough slack that you can push it in, make sure it's straight and tighten up, and it with the Teflon washer it tightens up nicely in the cut in the back. It holds it nice now. There's no flopping around at all, and that motor's now ready to test. I've assembled the dyno onto this plate, and I'm going to do a test of it to make sure it's working. The motor's clamped in there, 13.5. This is the speedo I'm going to use for testing things, a Hobbywing 3.1. I put these clips on the end so I don't have to solder it to the motor. Just make sure that right ABC order off of here. I've got the battery and the connectors through the current sensor, but we won't be using the current sensor. I'm just going to test the flywheel action. We're not connected up to a computer, so I've got a Servo Tester here, which is just can be used in place of a transmitter connected to the receiver lead. Now I've put the connectors for this on here. They're 5mm adapters actually. So you've got your positive and your negative. Always make sure that you don't reverse connect. So we can connect up, positive and negative. Now this speedo, when I press the on button, it comes on, and blinky mode. Everything's connected up, charged battery, speedo on blinking mode. The 13.5 set to blinking mode. A lot of advanced timing, it's about 6 amps free running. Calibrated. This replaces a transmitter, so I can use throttle and brake. So the belt is reasonably tight. It may stretch with time. Can't measure anything because I haven't got the computer connected, but we can make sure it works. So add a bit of throttle, starts up, I'll increase the throttle, makes a bit of noise, so the green light's on, that's the maximum revs, flat out. I'll turn it down and put it back to neutral. You can test the brakes of the speedo as well. I'll put the brakes on. And you can test your speedo, see if the brakes are any good or not. So it's working. Working very well. That's just using the clip-ons onto this 13.5. Speed control already getting a little warm, not much though. Obviously the batteries are going to be fine, and you might want to watch the motor. If you do a lot of running up and down, you're going to heat the whole thing up. So it's working good. The clamp works. There's no vibrations at all anywhere. The whole thing was nice. Next job to do is to connect the computer up to do more sophisticated tests. But just as a unit here, just testing speedos, your motor, but not getting any results, it works fine. There's not much you could do. You could fit a rev counter maybe somehow onto the shaft if you wanted to, but I think with the computer is the only way that you're going to get useful results. Turn off.